Hi, this video is for anyone with an interest in aircraft avionics, specifically vintage analog avionics. I have a few systems here, and this video will be a brief overview of everything you see, and I can go into detail into more depth in later videos, but I figured I'd show everything at once and see how that goes. What I've got here is I've got two analog radio altimeters, and I have here a ground proximity warning system computer. And this is the type that would, for example, if you're getting too close to the ground, terrain, if there are certain conditions that are set with your aircraft, like gears down, flaps are not set correctly, this device will warn you of those things. These radar altimeters differ from the barometric style in that they measure an actual ground height above ground level, whereas barometric is subject to, of course, the pressure settings and things like that. So using basically radar, downward facing radar on the aircraft, bouncing those signals, measuring their reflection, this will determine, the computer will determine exactly how far you are above the actual ground you will be landing on. So these operate from generally around between 5,000 feet and 0 feet above ground level. These two function at 2,400 and 2,500 feet respectively. It depends on the model, but basically this is what is used mostly during landings, but also it's active during takeoff. And that ties together with the ground proximity warning system because it uses the same ARINC 552 specifications in a height per volt spec that lets the computer know X number of volts equals X number of feet above ground level. And what determines that voltage is the actual the radar system that would be the sort of computer or brains of these indicators here. So normally these indicators would be hooked up in part of a larger system here. I don't have that system. I just simply have the ground proximity warning system here, or GPWS, and I've kind of worked it so that I can see the actual altitude that is presented to the GPWS in real time, as if I were landing with these guys here. These lights you see here, this one's a bit too bright. This one says GPWS in-op. This one says below glide slope, GPWS push the test, and DH, which stands for decision height. And the green test button is just an addition that I've done here for this whole setup. The two switches here control flaps and landing gear. So, the one on the left here is a TRT made by a French company, and this is a Collins Rockwell 339H-2, and it is made, I believe, in the USA. And they both functionally are very similar, but they differ curiously in their actual implementation, and I can go into that into more depth in different videos. But you'll get to see them both function here. The voltmeter there, which I realize is a bit tricky to see, is measuring the voltage directly to these indicators, roughly from about 0 volts up to about 30 volts, roughly, represents about 0 feet to the maximum, in these cases 2,500 feet. Technically 0.4 volts is 0 feet, but as according to the specification. So the ARINC 552 specification. So when the system is powered off, the in-op light is on, so that's totally normal. Let's go ahead and power it on. The DH light is lit because the TRT recognizes that I'm below ground level, so it's below whatever decision height is set. In this case, both are set to 300 feet. So whenever you're below that altitude above ground level, the DH light will light. In this case, this is that. So I'm not going to activate this one just yet. I'll show you just how the TRT works, and we'll go from there. So system is on. It has a really neat feature. If I can do a self-test here. So that's how I know everything's functioning. and we're ready to go. So I'm going to go ahead and just set these switches into as if they were in flying condition. So let's begin. Let's actually do it this way. So right now our flaps are in, we're on the ground. We'll go ahead and begin our ascent. The jitteriness of this one, you'll notice, as we approach 300 feet, that little arrow, that's the decision height marker. That's controlled by this lever here, this little knob. And you can see it both activates an analog spinner style counter. Apologies. And it will tell you right here what your decision height is. So let's get like a 300. There we go. And we'll carry on. So as I was saying, the sort of jitteriness in this is me being kind of rough with the potentiometer here. This one, unlike the Collins, also doesn't have a filter in it that filters out the signal, so it's a little rougher, but I think that's just how it is. Okay, so the way this normally would work is, let's say you're coming in for a landing. When you're above the maximum of the actual altimeter here, you would just see normally a black tape. Very normal. But as you begin to descend, you can see on the voltmeter there how the voltage is decreasing. Now if you descend too quickly, the computer may bark at you about terrain. I'm keeping it slow enough where that probably won't happen in this case. But at 500 feet, I'll get my first call out.
Terrain.
Okay, so I went too fast there, so the computer got a little scared.
500.
And that alert is normal. It just tells you you're approaching the ground. As we hit 300, in this case the DH set level, you'll hear that minimums alert.
Minimum.
That's letting you know that you're at your own preset height.
200.
Coming in for a landing. And there we go. So let's go ahead and do that one more time, except I'll show you some of the alerts and what can happen if you're not set correctly. So what I'm going to do is I'm going to put both my landing gear up and my flaps in a flight configuration, not ready for landing. Let's see what the computer says about that.
Terrain, pull up.
Okay, so this is because my flaps are not set for landing. So at this point I can carry on.
Terrain.
The computer will not let me carry on. The light stays on, letting me know, hey, you've got a condition here, buddy. Something is not right.
Terrain.
And I say, oh, okay, wait, my flaps. All right, flaps in landing position. All right, I'm good, right? Not forgetting anything?
Terrain, pull up.
Oh, that was a bit too fast.
Too low, gear.
Okay, it said too low
gear. Too low, gear.
Well, what's that? I forgot my landing gear.
Too low, gear.
Let's go ahead and fix that.
Too low, gear.
Gear's down. All right. And there we go. And I'm ready to land.
Minimum.
And there you have it. So you can see how the computer will again try and save your bacon by alerting you to improperly set aircraft controls, if your descent rate is too fast. There's also provisions to I'll warn you if your roll rate is too great. There's a couple of different inputs that each computer can handle, and this one has a bunch of them which I don't have inputs to. But again, I'll show you right now what happens if you go too fast or you descend too quickly.
500.
No, it's tricky. There we go. Sometimes it triggers, sometimes it doesn't. It's because the computer is sort of like wondering what's going on. How is somebody climbing 2,000 feet in about a second? So the computer may not register these inputs, these drastic inputs.
Terrain.
Yeah, there we go. Okay, anyway.
Terrain.
So yeah, that was because even though I was set correctly for landing, I was coming in at a very fast descent rate. So there we go. So that's the gist of it. Let's go ahead and look at the Collins unit. Now, you'll notice that the flag is out. Oh, worth noting, the TRT has a defective flag, so I've removed it until I can get a replacement solenoid. Anyway, this unit, as far as I can tell, the Collins, functions perfectly in all respects. And right now, it's in a condition called above scale. Even though a valid voltage is being fed to it right now, it is not responding to it. And that's because, as I mentioned, the Collins unit has a different implementation where it requires an extra external voltage of a minus 30 and plus 30 voltage reference input that would normally come from the actual computer itself, the radar computer. And that's kind of a check and balance. So if there's a malfunction with the computer, it'll say, hey, this is not functioning, don't trust it. So what I'm going to do now is I'm going to simulate that signal, those reference signals, and you'll notice it will then come down and be ready for input. So there we have it. So let's go ahead and repeat our tests. So we'll go ahead and zoom all the way back up. Now these are both being fed the exact same voltages. It's worth noting, again, the TRT on the left doesn't really have an input filtering, whereas the Collins is very smooth, much smoother. So again, here we are. Currently, I'll go ahead, put our flaps in a flying condition, and our gear is up, so the computer will bark at us. Let's go ahead and begin our descent. Now the Collins unit also has a DH, so I'm going too fast. Didn't like that descent rate. So if I slow it down, the computer should recover.
Terrain.
Nope. Oh, mind you, also my flaps are not in landing condition. So let me go ahead and fix that. There we go. Flaps are down. The Collins unit has an interesting alert, pre-alert, where at 50 feet above your DH, it will begin a tone that will increase in pitch as you get to your DH and then stop. You'll see that here as we approach 350 feet.
Terrain. Pull up.
Again, my gear is still up.
Too low. Gear.
Let's fix that.
Too low. Gear.
Gear down. All right, we're good.
Minimum.
And there we go. Minimums. The Collins unit has that alert, that pre-alert, and it has its own DH light. This is actually a button, you can reset it. So if you don't want to be annoyed by that, you can also, of course, what will happen is it will go off automatically if you go above. So if I'm coming down again, it'll also reset if I then climb above 50 feet above the DH, or 75 feet. And now we're good. And there we go, carrying onward.
200.
And there we have it. Unlike the TRT, which this light's connected to, The DH light is smart enough to know to go out when you reach ground level, whereas this one isn't. So again, both units are functionally the same, but the Collins unit is a little more complicated and it's a little more feature rich in the TRT. So there you have it. This is again kind of a 10,000 foot overview of the system here. Happy to go into much more detail into these individual devices here and how I have this set up. I probably will just anyway because it fascinates me still. I realize this video is a bit long, but I appreciate you working with me here, and I will go into all the details again in these particular components and how it all functions here. So thanks for watching, and catch you in the next video.